Hello guys, welcome to a new session. In this session guys, before developing variable declaration and assignments, we need to implement hash table. So why do we need hash tables? So first of all, we need to store our objects in the fashion like key and value. So the second reason why we implement hash tables is chain complexity, because in hash table operation like in insertion and searching and delete, it takes O of 1, big O of 1. So let's take this example of our int language, a simple program. We have two variables. First one called name, it's a string with value foo, and I have another variable called mean. You will know why I called that mean. It equals 20, and then I will print name and print mean. So what we need, so our VM needs to store name as key and value as foo, and for the other variable mean as a key and 20 as value. And when we have an operation, a statement like print, and then we need to get the VM needs to access that variable based on the key. So that's why we need key value. Remember guys, if our VM slow in accessing variables and inserting them, our whole language will be slow. So the time complexity is very necessary. So as you see as an example here, we have an hash table and we store name as a key and foo as a value, and the other variable mean and value 20. So our VM need that hash table, like we name it globals, to access this variable as they need. So the question that I need to answer, how do we know in which index we should store this value? So what we need to do is implementing hash functions and functions like insert, search and delete, and we should resolve the problem of key collisions. So here is an example of hash function. It takes key, the name, and it generates a number. So remember, hash functions, it take as an input a key and then it generates a number. So I just reverse keywords here and I get mean. It's simply name, but I reverse some keywords and I get mean. So a hash function will generate the same number. So this is what we call collision. So when we will jump in the code, we will treat that case and we handle this collision. So let's jump right to code. First of all, we need to go to our object.h and insert a attribute called hash to store the number of hash. So then I will include comment.h. So I save that, then I will go to object.c. Why object.c? Because in object.c we have functions that allocate object. So when we allocate a string object, we need to calculate its hash. So let's go and add, before allocating string, add a function called hash string. Take as an input a key and its length, string length, and then it will return a hash. What is that hash? We will define this variable called hash. We do a random value here, 2 1 6 6 1 3 6 2 6 1 U, and then I will loop over every character in our key until the end, and then you can search about this hash function. It's famous. We'll not get into details why it's like that. And then we will return hash. Okay. The second thing we need, it's we will update our allocating string. It will accept a hash. And then we will store that in the hash attribute, and we affect hash. So we will go to take string, and we update that. Also, I will declare a variable called hash. And I will use the hash string function, and we pass chars and its length, and then I will allocate on the string object, and I will pass that hash. Also for copy string, hash string. Okay, and we will pass that to allocating string. So guys, what we implement right now, it's a hash function that take a key and it generates a number. So we update the allocating string because we've defined a new attribute called hash in the object string structure. Then when we allocate that, we need to call hash string to hash that string passing parameter, and also for copy string also that we need to calculate its hash. So right now let's jump to so let's create hash table. Vim table.h. We'll do the basic stuff. We'll define our guards, and table h define so I will define a structure called entry. It's the entry that will be stored in the table. This entry, it's a key and value, and our table is a dynamic array called table. It has a capacity, also as count, and also as entries, a list of entries. So what we need, as usual, init table, and you take as a parameter pointer to that table. Also we need some helpful function that implement setting a value to the table, and we'll pass the key and value. Also we need a get function that will get a value based on some key, and we will write that into a variable called value. Also we need a function called to delete values, delete table, and we need to pass the key to delete. Okay. Before we implement these functions, we need to pass to our whiteboard to discuss these three functions. So, what we need to develop our hash table. First thing, we've developed the hash function. Second thing, we've just defined insert and search and delete functions. So what I've said, that hash function, it generates numbers based on some key, and it have the possibility to have collisions, and how we treat that we will see. So in the insert function, let's assume that we have this table, and this is its state. It's a hash table, and in the index 2 it has a value called name, and an entry called has a key called name, and the value called foo. So value is okay. Value which we want to store is 20. So in this example, I want to insert an entry that has a key called mean and the value 20. And remember, mean and name has the same value generated by the same hash function. So the hash function, it gets as an input mean, and it generates 2. But 2 is reserved for the entry name. So what we will do is we start from this 2, this position, and we increment our cursor by 1 and see if the next entry is empty, we store that in that place, and so on. Let's assume that we have this and this and this as the values. We will start from here, and we have value. When we get an empty, we store that here. You get the idea. For the search, let's assume that our target is this. Let's assume that our VM need to access this variable. The key is min, and the function, the hash function, it returns also the position 2. We have a collision. So it starts from 2, and we compare. Is it the key name is the same as mean? No, we pass to the next one. But the main idea is to start at the position that hash function returned to us. So you see, we've incremented by 1, and we get to that target. So for delete, it's a little bit funny and cool. The delete function accepts as an argument a key. Let's assume that we need to remove the mean key. The hash function also will return the position 2, but the position 2 we have name, so we need to increment our cursor from that position to the next one. So when we have our target, we need to tag that with a tombstone, some value. We will add some value here to define that entry is deleted. So is it replaced by RIP, rest in peace. So let's jump right to code and implement these three functions. And in other sessions, we will use that hash table to compile statements like var and print variables. So let's jump to the code. Let's write that. First of all, let's include some headers. Include command.h, and also we'll include object, and also we will include body.h. So let's implement these functions. So let's include a header called string, because we will use something like memcompare, and let's also include table.h. Also let's include memory.h. So let's define the first function in the table. Accept as an argument or a parameter table, and we initialize the capacity to be 0, and also initialize the count to be 0, and also initialize entries to be null. So let's define a helpful function called findEntry based on a list of entries, and we pass it a capacity of the table, and also the string key. We need to find some key in our hash table, but specifically in the table entries. So first of all, if entries equal null, we simply return null. So we will initialize our index. Remember, our key passed to this function, it has a attribute called hash. So what will I do? I will do a %capacity modulo capacity. Why is that? Because I need to because I have the capacity. Let's assume, for example, we have a capacity of our hash table, it's 5, and we have an hash table and hash number great. So I should do modulo, because I don't want that index to depass that capacity. So let's initialize an entry variable called entry. Also I will initialize another one called tempstone for variable that are deleted. So let's search about that key passed to that argument. First of all, I will do entries and index. I start from the index. So if entry key equal null, so it's a place where it's empty, or another variable that is deleted. So I will check that. If the value of that key is null, I will return based on tempstone. If the tempstone is null, I will simply return entry, or the last entry deleted. So else if tempstone That's to ensure that we have the first deleted entry. So else we need to check if the key is equal to the current entry key and the key length, because remember the key is an object string, it has a length equal to entry key length, and also mem compare will pass key and entry key and key length. If it's equal to 0, then they are equal. So I did do 3 conditions. Why is that? Because remember, if the key equal the key, that doesn't mean the string are equals. And also, if the lengths equal the lengths, that doesn't mean the strings are equals. So when we do mem compare the key and the entry key, then I guarantee that that key is equal the current key I am on it. So what we will do, I will return the whole entry. Okay, so I need to increment our index. I will do index +1, also modulo capacity to avoid the passing the capacity. So finally we will return null. The second function we will implement is table set table and object string key and also the value, and then I will check if table equal null, I will return false, and if table count +1 is greater than table capacity times some max load factor, I will explain why I need to use that. Here I will adjust the capacity of the hash table. Why do I need this max load factor? Remember, I don't want my hash table to be fully has no entry value, has no empty entry value. So I need to have some extra memory that are free. So to ensure that, I need to test if the count is greater than the capacity times some percentage. That percentage is the load. So that I will ensure that every time I will have an extra memory that is empty. So why do I need to use that? Because remember, in our find entry, it will keep going until it find an empty one. So if if my table is have no entry empty, it will keep going forever. So to break that, I will need to have a macro called max load factor, and it's 70%. So if the 70% of the capacity is not empty, then I will adjust the capacity. If the 70% of the capacity of our hash table is full, I need to adjust. So remember, I need always some extra memory that is empty. So I will return to that to implement the adjust capacity. So what we need to do is to find the entry and use the function find entry, and I will pass table entries. Then I will pass the capacity of the table and also the key. So I need a boolean value that check if it is a new key. So if the entry key is equal to none, that's mean it's a new key. So is new key and the value is nil, not a rip value or a thumbstone value. Entry value, then I will increment the count by 1. I increment the count in case that is a new key. So then I will update the entry by the new one key, and entry value will be the new value. And if that key doesn't not exist in the hash table, we will add that, because I will use that function that will return an entry in the position that is empty, and then I will update that. So I will insert that, and if the key it exists, I will just update that by using entry value by value. So I will return to that later to implement how we will adjust capacity of our table. So let's implement the next function, bool table get table, let's string value. This function, it will get the value of that key and it will insert it in that variable. So let's do that. If table equal null or table count equals 0, we'll return entry. We will find the entry, we will pass the capacity of the table and the key, and when we find the entry, what we need to do is to check if the key is none, so the value is not exist. Otherwise, if it is exists, I will put the value in the variable value and I will return true. So let's add final function table delete. They will delete a key, an entry based on some key. As usual, what I will do, if the table is null or table count, we have no entries, no need to delete something, I will do false. So then I will find the right entry to delete, and then I pass the key, then it finds the entry if it exists. If the key is null, so the entry it does not exist. So now we will do the rest in piece rep. What we will do is to delete the entry. In its key I will put null, and this I will tombstone that value by doing entry value, and I will put a boolean value like bool val true to say that this value has been deleted. So return true, the operation is successful. So let's come back to this adjust function, adjust capacity, and I will pass the table, and I will grow the capacity. Remember that macros that grows the capacity, and I will pass the old capacity. So let's add that function called adjust capacity to accept table and capacity. Say static function. So let's do that. We will allocate an entry table. Type is entry, and the size is the new size capacity. What we will do is to initialize every entry in that entries table, and then I will increment the index. So in entries, for the first position, what we will do, for key I will put null, and for value you get it, I will put near val. So it's an unused entry. What we will do is to initialize the table to be 0, because remember, when I grow the table, we need to redefine the position of all entries, because remember the hash table returned to us a hash number, and then we do the modulo of that to a capacity of the table. So the capacity of table is changed, so it means that the index of the entry it will be changed in another capacity. So let's loop over every value in the table. Let's remember the entry, the current entry. I will skip it if its key is null. Whatever, it could be a value that is deleted, because how do we know a value is deleted? Is just by the key is null and its value is a boolean value true. So in here, if we have a value that is deleted in our table, we just continue and don't process that, because we adjust our capacity. So the new entry will be find entry in the entries table, which will return the right position of that entry. And what we will do when we have the entry, we will pass it to its key, the entry key of the old table entries, and for the value it will be the entry value, and we will update the count of our table. So finally we will free the entries table in the old hash table, and then for the capacity it will be capacity, and the new entries of our hash table is the entries that we've allocated, these entries. So by doing that, we've accomplished something good, and we've defined the necessary functions of hash table. So let's recompile that project and see if we have something not good. So let's do compile clean make all. Okay, in vim object C line 27. Okay, in line 51, what we have is star, not stars. So let's remake that. Okay, so we have on the line, okay, in table C 30. Let's go to that in table C 30. It's called thumbstone. Right there. Let's see the other errors. Okay. Okay, what's next? Find entries 77. Entries. Okay, so let's remake that. Okay, what we have next. Equal null, and okay, I think that's fine. So all is good. Let's test our project. So let's do something. Hash table. So everything is good right now. So see you guys in another session. In another session we will implement something that needs hash table to be implemented. So we've accomplished a good building block, so the VM can store variables and access them and delete them. So see you guys in another session.